Hey there, and welcome. Today, we are diving deep into something you probably use every single day. Salt. Yeah, I know, it seems incredibly simple, right? But it turns out its hidden, invisible structure is the key to some amazing properties, like why it shatters, why it dissolves in water, and even how it helps power our own thoughts. So let's get into it.
So, have you ever really stopped to think about this? You drop a salt crystal, and poof, it shatters into 100 tiny pieces. But if you drop your house key, it might get a dent or maybe it bends a little, but it definitely doesn't shatter. They're both solids, so what's the deal? Why do they react so differently to the same kind of force?
Well, the answer isn't in what we can see with our own eyes. It's hidden in the invisible world of atoms. To really get why any material behaves the way it does, whether it's hard, soft, brittle, or bendy, you have to zoom in. I mean, way, way in, and look at the secret blueprint for how its atoms are all arranged.
And for salt, that secret blueprint is something called an ionic lattice. Trust me, understanding this one structure is the key that unlocks absolutely everything else about how salt behaves. Okay, so what in the world is an ionic lattice? Well, just think of it as a super organized three-dimensional grid. It's built from ions, which are just atoms that have a positive or a negative electrical charge. And opposites attract, so these positive and negative ions pull on each other with this incredibly strong force, locking them into this really rigid crystalline structure. Probably the best way to picture this is to imagine a perfect 3D checkerboard. You've got a positive piece, then a negative one, then positive, then negative, and this pattern repeats in every single direction, up, down, left, right. This perfect alternation of opposite charges creates an extremely stable and powerful bond. Everything is locked firmly in its place. And what's really wild is just how precise this whole arrangement is. If we're talking about regular table salt, that's sodium chloride, every single positive sodium ion is perfectly hugged by 6 negative chloride ions. And you guessed it, every negative chloride ion is surrounded by 6 positive sodium ions. It's this perfect balance that means even though it's built from all these charged particles, the crystal itself is totally, completely neutral. Okay, so we've got this super strong, super rigid, perfectly organized structure. But that just brings us right back to our first question. If it's so strong, why does it shatter so easily? It kind of feels like a paradox, doesn't it? Well, here's where we see the crystal's greatest strength become its greatest weakness. Imagine a force hitting the crystal. A whole layer of these ions get shoved over by just one single position. And all of a sudden, chaos. Positive ions are now lined up right next to other positive ions, and negatives are next to negatives. That powerful force of attraction instantly flips and becomes an even more powerful force of repulsion. The layers violently push each other apart, and just like that, the crystal shatters. So, that perfect structure is exactly why salt is brittle. But what's really cool is that the very same structure is also why it dissolves so incredibly well in water. So let's switch gears and take a look at how that works. The secret weapon here is that water molecules are polar. You can think of them as tiny little magnets, each with a positive end and a negative end. So when you drop salt into water, these little water magnets just swarm the crystal. Their negative ends latch onto the positive sodium ions, and their positive ends grab onto the negative chloride ions. They literally team up to surround and just pluck the ions right off the lattice, one by one by one, until that whole rigid structure is completely dismantled. All right, so we've seen why salt shatters and we've seen why it dissolves. But there's one more property that is honestly maybe the most important of all, not just for chemistry, but for our own existence. And that's its ability to conduct electricity. And here's the absolute crucial difference. In a solid salt crystal, remember, those ions are locked down tight in that rigid lattice. They can't go anywhere, so no current can flow. But what happens when we dissolve it in water? The ions break free. They're now mobile, they're floating around, and they are free to move through the water, carrying an electric current with them. It's that freedom of movement that makes all the difference. So why is this a big deal? I mean, this isn't just a cool chemistry fact to know for trivia night. This property, the ability of dissolved ions to carry an electric current, is fundamental to how our own bodies work. That's right. Every single thought you have, every move you make, every sensation you feel, it's all powered by tiny electrical signals. Your brain, your nerves, they're all part of this vast, incredibly complex electrical circuit that's running your body right this second. And as our source material puts it so perfectly, this property of ionic bonds is nothing short of a blessing. It's the whole reason our brains are able to send these electrical impulses racing through our bodies. Without it, well, life as we know it just wouldn't be possible.
I mean, just pause and think about that for a second. It is an absolutely incredible connection. The very same strict microscopic rules that cause a salt crystal to shatter when you drop it are the same rules that, when that crystal dissolves, allow for the complex electrical signaling that creates consciousness itself. It's amazing.
So, from a simple grain of salt, we've uncovered these fundamental principles that govern everything from geology to biology. And understanding these atomic rules doesn't just help us explain the world around us, it actually gives us a blueprint to design it. From creating stronger materials to building more efficient batteries, the possibilities are pretty much endless. It really makes you wonder, doesn't it? Knowing what we know now, what amazing new materials are we going to build for the future? Thanks so much for joining me.